This video demo shows one use case of our complementary situational awareness framework to assist surgeons in better understanding the surgical environment and improving robotic capabilities in limited information environment exploration. This demo focuses on exploring anatomy that has been imaged preoperatively, but that may have deformed in the intraoperative state, and on force-guided exploration for stiffness estimation of anatomy with uncertain geometry. We begin with automated exploration of a silicone phantom organ. Using a hybrid force motion controller, the Da Vinci patient-side manipulator gathers surface data in a user-specified region. This data is used to create an intraoperative map of the anatomy by deforming an a priori model of the anatomy to the exploration data using the coherent point drift deformable registration algorithm. During teleoperation, we use superimposed sinusoidal palpation to better estimate surface stiffness and height. You can see here our work on incremental stiffness estimation based on adaptive sampling techniques. This surface information is later used for updating the model environment. Due to the complexity of the CSA framework, this demo focuses on a simple use case where a constrained telemanipulation framework allows the user to palpate a phantom organ with a model-mediated force feedback system. The user manipulates the master device shown in the upper left to control the slave robot. Motion is unconstrained in the X and Y directions, but restricted in the Z direction via the interaction of a model of the slave robot and the registered a priori model of the silicone phantom organ. The model estimated forces are displayed by the red arrow in the bottom left. The user selects points with a gripper to designate the boundary of a virtual fixture that constrains lateral motion to be within that space. When the virtual fixture is enabled, the robot can move freely above the organ, but no movement is allowed that would push the slave robot out of the boundary. Alongside this constraint, we overlay sinusoidal palpation motion to provide semi-automated surface palpation to assist in stiffness and surface geometry mapping. This demonstrates our complementary situational awareness framework using the Da Vinci Research Kit to explore anatomy for intraoperative anatomy registration, model-mediated force feedback, constrained teleoperation, and stiffness estimation. Thank you for your attention.